Hello everybody, I'd like to welcome you to the video titled Classifying Rational Numbers, and you will need to get out your math journal and a pencil as we start going through this video. And first of all, the goal for this video is to understand how to classify numbers. So we're going to take a look at rational numbers, and also we're going to be taking a look at integers and also whole numbers and see how numbers fit into those different categories. Now, the first thing that you'll need to do is write down these two different vocabulary words. And the first one is rational number, and you'll need to write this down. So a rational number is any number that can be written basically as a fraction where a and b are integers and b does not equal 0. This is going to make sense in a little bit, so don't be too confused. So any number that can be written as a ratio of two numbers, think about as a fraction, where a and b are integers, and b does not equal 0. Now, we may think integers, oh yeah, that was a couple modules ago. What is an integer? It's right here. Integer, remember, integers are the set of whole numbers and their opposites. Okay, so when we think about whole numbers, think about positive 8, positive 9, their opposites, negative 8, negative 9. So that's what we're talking about when we are talking about integers. Okay, so basically the idea of rational numbers are basically any number that can be written as a fraction. Okay, so think about 8, that's a rational number because it's 8 over 1. If we think about 3 and 1/4, that's a rational number. Okay, because think about 3 and 1/4 can be turned to 13/4. Okay, so rational numbers are basically any numbers that we're going to be dealing with in 6th grade is going to be a rational number. So some examples of non-rational numbers would be pi. Okay, and when we think about pi, that is 3.14, and it keeps on going and going and going. That cannot not be written as a fraction because it is a continual decimal. So there's not a way to write that as a fraction. Okay, so some square roots would not be considered rational numbers because they cannot be written as fractions. So I hope you get a good idea of basically any number that we're going to talk about in 6th grade is going to be a rational number. So let's take a look at some of these numbers here. All right, so again, it's important to understand that with a rational number, or to figure out if it's a rational number or not, that means you can actually write it as a fraction. Okay, so let's see how we can write some of these numbers as a fraction. So negative 15 would be negative 15 over 1. Okay, so we can see that that is a rational number. 31 hundredths to 31 over 100. So negative 15 is a rational number. 31 hundredths is a rational number. 4 and 5 ninths. We can change this mixed number into an improper fraction. 41 ninths. And you can see that is a rational number. And then positive 62, any number that is just a whole number or even a negative number, it can always be written as that number over 1. So you can get an idea of why these numbers are rational numbers. And when you think about the definition of a rational number, again, any number that can be written as a fraction where a and b are integers. Think about integers. The idea of whole numbers and their opposites. That's an integer. Okay, so, and also b cannot equal 0 in order for it to be a rational number. So let's take a look at this Venn diagram, and it breaks it down pretty nicely for us, and we can see what is a rational number, what's an integer, and also a whole number. So you can see anything that's a whole number would be considered also an integer and a rational number. That's the way this Venn diagram works. Okay, so we can see that 35 hundredths, we know that it can be written as a fraction form. Therefore, it is a rational number. However, it's not a whole number or it's not an integer. If you remember, integers are the study of whole numbers and their opposites. So anything that's a decimal would not be considered an integer, okay, and also would not be considered a whole number. 3/4, we can see it's already written as 3/4, so we can see that is a rational number. However, it's not an integer, it's not a whole number. Integers, okay, remember the study of whole numbers and their opposites. So whole numbers, positive numbers, opposites would be the negative numbers. So I can see that -3 is an integer, and it's also a rational number. Why is it a rational number? Because I can write -3 in fraction form as -3/1. And finally, whole numbers, okay, we can see that whole numbers are obviously whole numbers. Any positive whole number would be an integer and also a rational number. Okay, we know it's an integer because it's a positive whole number. Okay, so integer there, rational number. The way we can figure out if it's a rational number or not, we can write it in fraction form, 75/1, and we can see how these different numbers, they go into those different categories. All right, so we can see that all integers are rational numbers. Okay, all whole numbers are also integers and rational numbers. However, integers are not necessarily whole numbers. Okay, so we can see, hopefully with this diagram, you can see the breakdown between the different types of numbers. Now what we're going to do, and I want you to do this with me, we are going to classify these different numbers. Okay, so we have 13 and 1/10. Okay, so think about rational numbers, integers, whole numbers. Basically, you can think about anything that has a decimal or anything that's a mixed number is not going to be an integer or a whole number. It's only going to be a rational number. Okay, so we can see 13 and 1/10. Okay, we can see 13.1 is a rational number, and in your journal you can just write R here because it's only one of these three. 9 and 1/5. Think about, can you turn this into a mixed number? I'm sorry, into a fraction, and you can. All right, so it's going to be 14/5, and so because we can do that, we know that is a rational number. Okay, and for this you can write R next to it. Now let's take a look at -9. -9, think about definition from a rational number. Can it be turned into a fraction? Yes. Okay, so -9, a rational number, also integers. Think about integers, the study of whole numbers and their opposites. Okay, so whole numbers and opposites is -9. -9 would be the opposite of +9, so that would be considered an integer. It's not a whole number because it's not a positive number there. Okay, so we can see also that a -9 is a rational number as well. So it falls under that big circle of rational numbers. Integers fits in that as well. Okay, so it's a rational number and it's also an integer. Now let's take a look at 101. All right, so can it be written as a fraction form? Yes, remember any whole number can always be written as a fraction over 1. As a fraction over 1. An integer, think about an integer, the study of positive numbers and their opposites. So it checks the box for rational numbers, checks the box for integers. Whole numbers, we can see positive whole numbers. Okay, in other words, it's a positive number. That's not a decimal or anything like that, so it would check the box for that. So if a whole number, you can see, is going to be a whole number, it's going to be an integer, and also a rational number. So all three of these. Okay, whenever you have a positive whole number, it's going to be a rational, integer, and whole number. Okay, now let's take a look at some of rational numbers, integers, and whole numbers in a real world type situation. So let's say you have members of a certain group and they're going on an outing together. Okay, and we have the J group. All right, Joe, Jill, Jim, John, and Jane. Sounds like a fun group, you know? So we can see that they have candy, and they also brought bottles of water. All right, now let's say, for example, this is a nice group. They all have the J in common, so they all really respect each other. They're going to share their candy evenly. Can you imagine that? I know I cannot, but they're going to do that. So they're going to share their candy evenly amongst everybody. And if you need to write this as a fraction form or try to figure out how much candy that each person will receive, what you do first of all is you're going to write this as a fraction, okay? And I can see that the first step, my numerator is going to be how much candy I have. So 3 plus 4 is 7, plus another 4 is 11, plus 2 is 13, plus 1 is 14. So 14 total pieces of candy. That will go as my numerator. And I have 5 people in my group. Okay, so basically what you could say is they're going to divide the candy by 14/5. Now that may seem a little odd. What we can do is change that mix or that improper fraction into a mixed number. Okay, so I can have 5 goes into 14. That's going to be 2 times with 4 left over, and my denominator stays the same. So everybody within the group would get 2 4/5 of a candy bar. Okay, so if everybody wants to share the candy evenly, 4 2/5. So you can see that 4 2/5, if you think about our lesson, that would be considered a rational number, not considered an integer or a whole number, just a rational number there. Okay, so let's take a look at the water now. Let's say this group wanted to divide the water up evenly amongst everybody. Okay, so what we do, first of all, if you're going to write this as a fraction form, we add all the water bottles together first of all. So 6 and 4 is 10, plus 5 is 15, plus 3 is 18, plus 2 is 20. So 20 total water bottles. I have 5 people, so 5 is going to be my denominator again. All right, and so what I do now is I just turn 20/5 to make it even a little bit clearer to myself, because if everybody, they divide it 20/5, that seems a little odd to me. We don't really speak in those terms. So making it into a mixed number is helpful. So what I do is think about how many times 5 goes into 20, and that is 4 times. Okay, so we can see that everybody would receive 4 water bottles. So this concludes the video on classifying rational numbers. If you have any questions about this concept, please come and see me.